Well, welcome everybody to Roundtable episode 10. We've made it to double figures, and to celebrate, we are joined by the one and only Adam Meakin. Are you there, buddy?
I am, mate. Good evening, everyone.
Nice to have you on, Adam. It's I don't know if you've done a presentation before, have you?
No, I'm only. This is my. All the people that applied haven't quite got their ducks in a row, so this is my help a mate out. No, funny, mate. Funny to revisit this as well. Like I said, this was something I did many moons ago when I first started on my journey, looking in it as a baller, and knowing that 8 inches were wrong, and not being happy with an approximation. Thinking, if I'm going to look into this properly, I've got to have a tool that allows me to find those sort of nuances, which I assumed would be there certainly over shorter distances and the like. So, and it's applicable overall. Unlike, well, I'll leave it to the presentation. But
okay, just one small thing I would like to say, that some people might disagree that 8 inches are never wrong.
No, I won't moan. But I can always do it twice, Shane.
Okay, maybe it went over your head, that.
No, I didn't. That's what I said. I can always do it twice, mate.
Right, I'm going to play your video, bud. If you want to pop yourself on mute. And,
yeah,
because I know you're watching the cricket as well, so I'm sorry to have dragged you away.
That was just bad time. It's 203 for 5, 39 from 24 balls. Come on, England. Come on. Right, I'll press play. I'll be quiet.
No worries, no worries.
Good evening, everyone. My name's Adam Meakin. I'm part of I'm Rail Media, and this is a presentation I did back, as you can see, back in 2017. Why? Well, this is one of the first things that I tried to do when I started on my flat earth journey, chatting with Rob and John Savage particularly, and it was one of the things that I wanted to do myself when I wasn't a flat earther, just to instantly prove to myself it was a ball. So it was something that interested me from the start. I like a bit of maths, so it was something I just my strong suits, just applied myself to straight away with great failure. The first attempt of a formula was shocking. Didn't take into account the size of the ball. Worked geometrically and angular, but not actually with regards to applying the drop across a distance. Second one used angular vectors, which is great. It allowed it to go into 3D if needs be, but was really convoluted. And then this is the third one, which is basically me starting from scratch and trying to do it myself from first principles. As I said, I didn't know which presentation to do, so I thought I would start at the beginning, and there we go. I mean, even before I was a flat earther, I was and looking at 8 inches per mile squared, I was aware of what it was. It's just a formula. I'm not going to go into too much detail, but it's just a function that is an approximation, but it isn't accurate for any distance whatsoever. When you apply, even down, if you think to some of the arguments, people will go 77.98 inches. So if you apply that, then obviously you can see the error just in of itself. It is close up to 100 miles, and I think for any just curiosity observations, 8 inches is still sufficient. But said the actress to the bishop. But I think if you are going to be doing actual real calculations applying this, then for me, and this is the purpose of doing this. I thought it would be a useful tool for fellow flat earthers and ballers alike. I don't think this presentation shouts flat earth or ball earth. It's simply a presentation of hopefully a useful tool. So what I want to kind of do is make a curve calculator with it, which is kind of what I set out to do. So there's a few things we're going to do. The first thing I'm going to do is assume that the Earth is a ball of radius 6,371 kilometers. Then, like I said, from first principles, we're going to calculate the number of degrees in 1 kilometer of radial straight line travel. So that's equivalent to, traveling around the circumference of the Earth. We're going to define a mathematical definition of drop or curvature created by the travel. We'll use some of the diagrams that we create to postulate a premise for a formula, and then with that idea in mind, use some trigonometry to calculate triangles, and then combine all of the above to hopefully create a curvature calculator. So the first thing, as I said, is to calculate an equivalence of how many degrees of radial travel I create by moving 1 kilometer around the circumference. So if we just take some definitions, we can just simply derive and calculate this. The radius of the Earth is 6,371 kilometers. Circumference is 2 times pi times radius, which is equal to 40,030 kilometers. From the North Pole to the equator is 90 degrees, or the quarter of the distance, or 10,007 kilometers. So we can say that in 90 degrees there are 10,007 kilometers. So in 1 kilometer travel along the circumference, there is 90 divided by 10,007, which is equal to Mr. Savage's favourite number of 0.00899326161. But for simplicity and to please John Savage, we've done the Savage reduction, so we'll refer to the angle as 0.009, which is a lot less of a mouthful. Excuse me. Okay, so we've now been able to define angle A in terms of distance. So we can say that angle A can be defined as the distance times 0.009. That's a statement we'll use later. It's obvious and derived from the previous slide. Next, we're going to kind of, from a mathematical point, trying to define what we mean by drop. So for me, it's defined by the yellow horizontal line, which is determined by the distance from the point of origin, which is here at the top of D1, and the drop can be expressed as the distance against the initial radius, which is D1, when we've travelled the green line to here. So we create angle A, and we can see here if we draw a straight line across to intersect the radius, this creates two parts which we're going to define as D1 and D2, D1 being the point of what we would call the drop. We can also say that actually D1 plus D2 is equal to the radius, but we are interested specifically in trying to calculate D1, which is the drop. So if we rearrange this formula, we can say that D1 is equal to the radius minus D2, and we'll, as with the previous thing, we'll save that, what we've defined for later. Now, trying to calculate D1, we can't simply define D1. It's quite difficult. It's, as you can see, it's defined by two straight lines and an arc. Excuse me. But D2 is quite straightforward, because these lines create a right angle triangle, which enables easy calculation using trig. We've got angle A, which we've defined from the distance already, so using trig we can find d2. We can use the radius itself, which is the long red line, equal to the hypotenuse, and d2, which is equal to the adjacent. So using the SOHCAHTOA formula, we've got the adjacent and the hypotenuse, so we're going to use cosine. So with that in mind, we're going to then define d2 trigonometrically. So cosine of A is equal to the adjacent over hypotenuse, therefore cosine of A is equal to d2 over the radius. And again, we're going to just rearrange this a little bit so that it's more useful to us later, because we're trying to find out what d2 is. So we'll just rearrange that so that we can make a statement to say that d2 is equal to the radius multiplied by the cosine of angle A. Now, drop or curve is d1. And the statement we've already made here, because we're going to try and put this together a little bit now, I think. So we've said that d1 is equal to the radius minus d2, and we've said that d2 is equal to the radius multiplied by the cosine of A. And we've also at the beginning defined that angle A is equal to the distance that we're inquiring about with regards to drop, multiplied by 0.009. So if we try and stick this together a little bit now, given that we've said that d1 is equal to the radius minus d2, and that's kind of what we said earlier, we're trying to find out what is the drop, and we know that d2 is equal to the radius times the cosine of A. So if we were to substitute d2 into that top equation, that gives us the radius is equal to the radius, the radius is equal to, d1 is equal to the radius minus the radius multiplied by the cosine of A. And we know that the radius is 6371 if we stick that in. And we also know that A is equal to the distance multiplied by 0.009. So if we put that in, it ends up with the drop is equal to 6371 minus 6371 multiplied by the cosine of the distance times 0.009, which sounds a mouthful, but that's the formula there surmised. So it's 6371 minus 6371 times the cosine of distance times 0.009. Now that did sound a mouthful, so I always did this initially for Rob's, and it is actually quite simple to do on the calculator. So you just take the distance you're inquiring, multiply it by 0.009, then you take the cosine of that, you then multiply that answer by 6371, and then just take away 6371. So that's just the calculator steps, and that will then give you the drop in kilometres. Obviously if you want to convert to metres, multiply by 1000. I have tweaked it a little bit. I won't go into too much detail, but if we were to assume and convert to miles, then the equivalent formula is equal to 3959 minus 3959 multiplied by the cosine of the distance of 0.0145. And that's my presentation. I hope that was understandable and coherent, and back to you, Ranty.
Thank you very much, Adam. Thank you very much indeed. So, how's the cricket going? Are you still there?
Yeah, I'm back. Sorry, 23 from 11 balls, mate. It's twitchy bum time.
We need to score 23 from 11 balls. Wow.
Yeah,
okay.
just
Well,
under 2 overs.
I think we should play some music, and hopefully we'll get a little bit closer. So, Give us 5 minutes, Adam. We'll be back, and hopefully with some good news. Good news, hopefully.
We're up pretty high, our heads are almost in the clouds, and their feet are chained to the ground with their chains of misery. They've got a hold of me, they won't let go of me. Let go of me. They might have gravity on their side, but something's pulling us high. Got the potential to fly. So let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? They can be cruel and mean and a huge pain. Our heads are in the clouds now. Don't let them make it rain. A smile can be the sun they're missing out on their rainy day. They might have gravity on their side, but something's pulling us high. Got the potential to fly. Don't let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? You defy gravity. They say we aren't strong enough, we don't have what it takes. I say yeah, they're wrong enough, and we'll show them someday. They might have gravity on their side, but something's pulling us high. Got the potential to fly. Oh yeah, don't let them be what holds you back from this one incredible chance. They're lucky to have had a glance at you. Are you defy gravity? You defy gravity. You defy gravity. Yeah, yeah. At you, are you defy gravity?
Early one morning, with time to kill, I made a decision and took the red pill. I saw a lone theory that Earth was a plane. I laughed just a little, thought it was insane. The more that I listened, the more it made sense. My heart, it was pounding, my feelings intense. The earth, it stopped spinning. A voice softly said, the ball is is dead. The ball
Are you there, Randy?
is dead. I started researching all over the net for proof of the space ball. I ain't found none yet. I kept on searching, but all that I found was fakeness of footage and proof of flat ground. My mother, she asked me, do I feel okay? I turned to her sharply and heard myself say, the earth, it's not spinning. My eyes, they turned red. The ball is dead. The ball is dead.
Randy, are you there?
Here in my bedroom, alone with
We lost 2 wickets whilst that happened.
of CGI
15 from 6. It's getting hairy. But I'm glad you're back.
Yeah, we can pause it right there. If you're back, how are we doing?
15 for 6
15 for 6. It's not going to
is what we need. 15 runs from 6 balls.
It's not going to happen, is it? Let's be honest.
Getting pretty close. We just got a 6. We lost a wicket. Then we got a 6. Then we've just lost another wicket. So it's getting close.
Right,
But
well,
anyway, go on.
I need you with your head on. I need you with your head on because I'm going to be looking for some questions from the chat. So keep your ears pinned back and we'll take some questions. Hopefully somebody's got something about the presentation. Maybe something completely different because it's kind of one of those topics that it's more of a demonstration than a presentation, you know? Well, do you know what I mean?
Yeah, totally. It's just, like I said, it's one of the first things hopefully more important, it's a useful tool. I said, if you're doing some of your calculations and you are trying to get into finer detail, then it is there for calculation purposes. So 8 inches per mile is absolutely fine looking across the sea to see that you can see things you shouldn't be able to see. Yeah, but if you were calculating it from like in a lot of the work you do, then those inches, feet in some cases make a difference. So in my book, like I said, I set out as a baller doing this, you know, but it was always important to be accurate, and hopefully it provides that accuracy. I said it didn't really exist in the metabunky things, weren't they? You know what I mean? And even with metabunk, the calculation as to how it's derived isn't there, and that's hopefully what I provided there, a little bit of an explanation as to how it's derived, so that you can understand it, that it's correct, and it takes into account both the size of the ball and the relative distance travelled along any supposed circumference to calculate it, which was some of the problems I encountered kind of putting all that together to make the formula work, because like I said, I've done previous stuff which hadn't.
Well, we do have a question from Mojo Shop who asks, can you reiterate your final results, and is there any way to calculate a pear shape?
Oh, not with that formula, no, that uses basic growth of a ball, which is based on a radius, so it's standard, you know, it's not changing, whereas a pear is, I mean, an ellipse would be hard enough, never mind a pear, which has got all sorts of curves and wobbles in it. So no, I'm not, couldn't.
Okay, so from Sleeping Warrior, this is a really important flat earth question. So he asks, is Federer better than Djokovic?
I don't know who won. I've not been watching the tennis. I had the Grand Prix, and I've got the cricket on now, so I've no idea what's going on for you.
How are we doing? Have they bowled a ball yet?
It's three runs from 2 balls, mate. With that, honestly, it's proper nipping bum.
We need 3 runs from 2 balls. Wow.
Yeah.
What happens if they rolled it across the floor?
Well, you can slap it.
Okay. Right. Okay. What's Adam's?
Would it be in the spirit of the game, mate? And therefore, that would not be cricket, would it?
The old "it wouldn't be cricket" line. I like it. What's your view on the perspective not taking account in the curvature calculator results?
What's my view on perspective?
Yeah, being omitted in the curvature calculator.
Well, like I said, that is a curvature calculator. It's a geometric calculator for topography, of how the topography should change relative to yourself. It's not an observation calculator. And as yet, I don't think there is an observation calculator out there. It's a very difficult thing. I don't think it's been truly defined. If you look at all the things that, as you know, mate, come into variance and affect what is observed, that's a very different thing to just calculating how, if we were on a ball, the land would fall away outside of the, just even flat sea would fall away, and that's not observed, but that's the reality. Yeah.
Okay, so from Spinning Monkey, so more of a statement, more like pear-shaped. You should have put them in brackets, perhaps. You mongs always latch on to something you don't understand. Well, what would you respond to that?
It's just an insult, isn't it?
Hmm.
It didn't even clarify which bit of the formula that I derived from source. It's not like I've stole this formula. I've derived it from scratch, from principles. So to suppose that something that I've derived from first principles I don't understand is nonsensical in of its own statement, isn't it?
I think what he means is when we say like pear-shaped, he's criticising the way we term it like pear-shaped, because Neil deGrasse Tyson said shaped like a pear.
So if he's asking for a kind of a, do I think when Neil deGrasse Tyson describes it as slightly chubbier around the middle and at the bottom, do I think it actually resembles like a pear? No. It's a bit like when I was on Ballbusters the other night, and I was describing with regards to the major and minor axes within the ellipsoid, just the basic ellipsoid shape. Okay, it's nothing that is accentuated in what you would think of the shape of an ellipse. It's virtually like a circle, but as I said, the difference I think there was 13 miles between the two radial differences. So no, I do understand. I don't think it looks like a pear. But
how's the cricket going?
2 runs from 1 ball.
Oh my goodness. Right, okay. Tell us when he's running up and we can listen to you cheering or not.
Mate, my legs are bouncing. Go on.
Is this the World Cup or something?
Yeah, it's the World Cup final. England versus New Zealand. So, and I just want to thank Rob from Iron Realm for supporting New Zealand and therefore giving this game some actual significance to the result, because that's what I want it for most. So this is the last ball. Here we go.
Talk us through it.
Whoa. That's it. We've got the one. We've drawn the game. We've drawn the game. Oh, he's run out.
He's run out? Oh, why didn't he just settle for a draw?
Gotta go.
What?
We've drawn. We got the first run. No, I think he's out. Just not getting it. That was soft. Should have took the draw. Oh, he's clearly out. Oh, he's clear. He's not even in the picture. Oh, he's gone. Country mile. So anyway, go on then. Next question.
So they don't get the point. They don't get the point there, Adam. That means that New Zealand have won.
Yeah, I know.
They should have just settled for the draw. What were they thinking?
I don't know. That's why I was just.
Oh well. Right.
Anyway, that's there you go. Finale. Waste of a bloody afternoon.
Okay, right, let's see. From Celtic 67 wants to know when I'm at work in the morning. That time. That's what time I'm at work. Right, so I'm just looking for some questions actually because I'm having to read through these to catch up. Can you see anything in the chat? Are you actually there looking at the chat? Or
No, yeah, I'm watching the bloody cricket, wasn't I? I apologise. I know that's poor form, but I'm there now. Is there anything? Let's have a look. Bristol City football supporter. Yeah, well.
Okay, so you're getting a little bit of support there from Brian Q. Vincent, who says he agrees about starting from scratch. He did the same thing for kinetic energy in the supposedly rotating Earth using Newtonian mechanics. The Earth must be stationary. So yeah, so it's like what you've done. You've brought things back to scratch and started over to check, what you've been told, basically.
There's one there I've just noticed, Randy. Sean Little G at Randy. Should the angular size reduction be figured, then use the number in the curve calculator? Yeah, that's one thing that you should do. That basic reduction of size over distance is a primary thing you've got to stick in. It's a bit like the curve itself. For me, you put the geography, the topography in first. So you lay out what the actual thing is you're supposedly going to be looking at is actually shaped like. That's what the curvature calculator is for. But then if you're then going to put angular size reduction in, then you apply that. I don't think technically it would make a difference in any calculation, but that's the way I would envisage to do it, is you would build upon the formula, because I started out saying that, those two things would have to go in, but as we know with optics, there's a lot more that then comes into play with regards to distance and perception. So, and that's way out of my field, you know what I mean? That's what we're all learning still, in it now. All these different factors. I don't know how many Tim Osman had got to. I don't know what the number was, but there's all those considerations that you can either rule in, out, or then if they're in, decide what level they're being and affecting at.
Okay, so we have a question from Gleam, who says, discuss how the Earth could even get pear-shaped without there being an up or down.
Yeah, that's an interesting one. That I agree with that, because I often thought of that when they do the lab experiments and the spinning, you get the standard oblateness created, which is derived from the centrifugal forces and the squishing of any sphere that they create. But why, like you say, if there isn't an up and down, why that would then apply differently to, I want to say, up and down again. Do you know what I mean? The north and the southern, in their paradigm, there is no difference from a physics point of view in terms of forces being applied that would deform the spheroid, that would surely differentiate between the two northern and southern hemispheres of that rotating globe. That is something I don't know why, mate, to be honest. I understand the concept, I think.
Right, so I've just done my first ever banning from Celtic 67.
What did he say? Go on, tell me.
So his comment was, do you think rubbing a bit of paint on your face and carrying a ladder around once proves you're in the trade? Lad, I know what you're doing all day and it ain't painting. So essentially, I don't have time for this kind of shit. This platform's open to anybody, but when you come in it and you literally provoke me and do this over and over again, I haven't got the time to listen to your shit in the chat. So welcome to being the first person banned on this platform. I've done 10 shows. I've been allowing people to say whatever the hell they want. But dude, get over it. Get over yourself.
that proves it. You see, he's attacked your trade, and that's forced you to do your first ban. Hey, I'll vouch for you, Ranty. Right, we were setting up this show, and before he put the green screen up, he had this wallpaper. I mean, it weren't my taste in wallpaper. Don't get me right, you know. but what because I do all you know, I know I'm a chemist, but I was taught to do wallpapering as a young lad by my dad. You know what I mean? And I love doing it. I find it really very therapeutic. It's quite calming. But the quality of your wallpapering was spot on, mate. So either he's a bloody good amateur, but I think actually from that reaction, look at that. I know you're not a painter, and you've seen your arse and kicked him out. So
it's just, you know, I mean, I just don't need it anymore. You know, I mean, literally, you know, people can come in. They've got a platform here from any side to come in and talk about anything they want, but there's just no need. You know, I am a painter and decorator. Who cares? What's the big deal about it being, you know, that is my job. That's my trade. That's what I do 5 days a week. Does it really matter? You know, so when you're calling me out on that, I mean, I've got my own Facebook page with all my images on where I've been doing work, and, you know, it's just ridiculous.
Government set that website up, mate.
Oh yeah, that's right. Yeah, because I'm some kind of shill. Anyway, let's back to the questions. Because I don't want to give him more time than he's worth, because he isn't worth it. You know, he just riles me up. Right. Right. Let's see. Can you see anything in the chat?
Let's have another look. We're coming out. We did draw it. We've drawn it. It's a draw. I don't know what's going off now. I don't know what the rules are.
It is a draw.
Yeah, he got the run.
So you get a run even though you get run out?
Yeah, I thought he did. That's what I was. But then you made me doubt. But something's going on.
That can't be right.
It is. He got the run. He scored the run.
Really?
Yeah. So I don't know what's going off.
I thought if you have to stop when you stop and collect the run. So if you try to go for a second run and you get run out, then you don't get the first run. So that's how I've always believed.
Yeah, you get the runs you've banked, I think. Well, I don't know now. They're out, mate. They're out. So who knows? I'll keep people updated. No, I've not been looking. I do apologise. That's your job.
Okay. Well, I think Jeranism's going live later today, so I think in probably an hour he should be live. Do you know if he's doing anything particular? I've
no idea. My Sunday nights have been ruined, mate. Ruined. The routine has been. It's gone to shot. It really has. But look, on tonight. Look, hopefully, like I said, hopefully it's a useful tool. I do think it is correct mathematically, given the assumptions that it makes in terms of the shape that you're measuring. I've not seen any critique mathematically in terms of suggesting it's incorrect. So I'm quite chuffed about that. So yeah, there you go.
Okay, so there was a question asked and now answered by Sean Hawkins. So would you agree with this? He says, which curve calculator would you recommend? And Sean Hawkins has responded by saying the Walter Bislin's advanced curve calculator. So would you agree with that?
No, I think I've had a look at the Walter Bislin's one, and that is one that does excuse my French. It applies the geometry and then applies a reduction in angular size. Like I said, as we were discussing, I think there's a lot of other things that come into effect, and I've not really. I looked at it a while back and made a bit of a boo-boo, made an apology in terms of the way it's working, and I addressed that and haven't really seen it much, because it is, as far as I can see, just applying that, but it does look a little odd in of itself. I suppose it's something, if the ballers are going to start using it and citing it as a tool that's applicable to using in observations, then I suppose it might merit, a re-review. But I say it's not something that I've paid great attention to. But if the ballers are now citing it as this is definitely correct, and this is the thing you should use when you're analysing a photograph, then I I suppose it needs probably tearing a new one, but who knows?
Okay, so Wake the Sheeple says, tell Adam to say, well, he's saying hello to you basically. He was the guest apparently on episode 33.
Episode 33 of Iron Realm.
I would assume so, yeah.
Legends, you see.
Legends. But it's at number 33 now. People are going to come
Yeah,
back and think.
I was about to say that's sus in it.
Yeah, that's it.
Yeah, funny. Shout out to Zach. Seen him in the chat. You all right, bro?
Okay, so from Daniel Leather, who says, don't the curve calculators just claim light is curving around the curve of the Earth due to gravity when explaining how we see too far?
Sorry, we're in a super over, so it looks like we've got an over each. We've got 8 from 3 balls so far. So anyway, carry on. Repeat that question.
Don't the curve calculators just claim light is curving around the curve of the Earth due to gravity when explaining how we see too far?
I'm not sure what the full causative effects, and I don't even think Mick West does, as to why when he applies an arbitrary 7/6R value to the straight line, which helps it stay in shape with the ball, even though not totally 7/6R. Yeah. I don't think I think most of it's to do for refractive effects. I don't think anyone's ever suggested that the gravimetric effect is pulling photons towards the centre of the Earth. As far as I'm aware, I think that arbitrary 7/6R is derived from a standard amount of assumed refraction, as far as I'm aware, Randy.
Okay. Right. Not seeing too many more questions coming in, but so
Have you
far
ever heard it linked to gravity? I'm just kind of racking my brain a bit there. I've never heard it linked. Have you?
No. Well, I'm not. Listen, I don't want to agree with all.
I know you're not
disagree,
allowed.
so-
I've answered the point. It was just a question for you. I didn't know if you'd ever heard it linked to it. But
Well, I'm not going to answer that. 'cause
I think you're not. Big deal. I was
not
probably going to
my
ask
thing.
you again. So I just say, just a point of conversation, Randy.
Yeah, I think most people in the chat probably already know the answer. So, I just don't want to go down that route of answering your questions for you.
Well, I tell you, I heard a bit of one of Brenda's answers with regards to the gravimetric differential between why you're not slightly lighter during the day in relation to the pull of the sun. Well, the differential there between a photon and the Earth, I would suggest, is infinitely more than than a human being and the the sun. So I don't think that gravimetrically, that from a gravity point of view, you're going to get the level of deviation caused by an applied force to match with that. If you that's probably a better off the cusp answer.
Okay. In the chat.
Assuming gravity is a force and it could, exert a force upon a photon, which is nonsense in of itself. But
Okay, so from Mark Collard, who says, light travels in straight lines. When the solar eclipse in 1919 proved Einstein right, in inverted commas, it barely moved the path of light. Yet, we're supposed to believe the gravity of Earth makes light curve.
yeah, it's a bullshit experiment, that, isn't it? It was one of those things that we've discussed this on Iron Realm a bit. With a lot of the way that physics was heading, I think Einstein was kind of kicked in to touch a bit early, and what you see here was part of the support for his, I think, early release was to try and provide an experiment that would do this. And they did notice that there was going to be this solar eclipse, and they would have sight of a certain star, I think somewhere in Africa, and they rocked off over to there with a piece of shit. You'd spend 50 quid on Amazon and get a better telescope than they rocked up there with to do this theory proving experiment. And basically, it's a load of them in come back from Africa with some numbers on a piece of paper, as far as I'm aware, that confirm Einstein's theories. So it's not something that has any real validation. Certainly not to announce it the way it was done. As far as I remember, it's again subtle details of certain events is.
Okay. Right, a massive shout out to Earth is Seriously Flat again for smashing the super chat and says, ask D Globez Zombies how to test the distance to Polaris. That's the question. Would you know how to answer that, Adam?
Well, I'm not a Globed zombie, but you'd need a really, really big tape measure is the way you can validate it from my point of view.
Okay, well, tomorrow's show, I have a vacancy. So if there's any Glober in the channel or is watching this on playback who can, at the very late, be a very late stand-in for tomorrow's show, I would appreciate that. So I'm looking for someone, as I say, tomorrow to do a 6 p.m. BST London time slot. Put a presentation together. I know that there are some people in the chat who have contacted me before. I'm not going to name any names, but I know that they have emailed me personally saying that they want to do a presentation. Well, if they can get a presentation up and ready, or perhaps do one on the fly tomorrow, I would welcome that. We have Spurs Chemo in on Wednesday. Now, Spurs Chemo is jumping up and down about his presentation. Jason McCormack, Ranty wants a concaver. Yeah, I mean, listen, if a concaver wants to come in and do a presentation tomorrow, I will welcome that just as much. But on Wednesday, yeah, Spurs Chemo wants a lot of hype about his presentation. So I'm going to give him the hype. I also, you know, if Jaren's listening or Bob's listening, to mention to Jaren, maybe give it a mention tonight, because he wants as much exposure as possible. So it's either going to be a massive flop or it's going to be a massive success. But either way, he's literally pinning everything on this presentation this coming week. So big shout out to Spurs Chemo. So yeah, if anybody can do a show on tomorrow, please email me. That will be ranty@rantyflatearth.com. And yeah, is there anything else you want to say, Adam, before we wrap this up?
New Zealand needs 16 to win from 6 balls, mate. It's their overs coming up, so can't believe this game's outlasted. Hang out, they've dragged it out for it. It's been a pleasure, mate. Like I said, hopefully, you know, down the line, I'm no quantum eraser. I don't need to be on every week, but hopefully down the line, I've got a few other presentations I've done over time, which are probably a bit more contentious.
Yeah.
So I'd be more than happy to do them as we move forward. They're already on there on Iron Realm Media. That's Iron Realm Media. You can find us on the YouTube channel. You could also find the boys on TFR Radio on the Ironworks. That's Tuesdays and Fridays at 10 p.m. till 12 p.m. UK time. Break clear of the fear. Walt would be so proud of me there. I can't believe I got all that out without stuttering. Chuffed. Boom. To quote Jose.
I just had a massive mind freeze then, because I wanted to say something and I've completely forgotten now. Oh, yes. This coming Thursday, Adam, I know you've been on the show twice, and I don't mind you coming back this Thursday either, but I did want to try and sort of like vary things up a little bit. So this Thursday, if there's
You bastard, you're dumping me live on air, aren't you?
No, I'm not.
I know what that
dumping
is.
you.
I had girlfriends, mate, back in the day. I know what that is.
I want to keep things a little bit fresh. So because you've done a presentation this week, I think it's unfair if you're judging this Thursday. So
I'm not having it. I'm not having it, because this is my chance to oust Gem Panda. So you're saying I'd lose my vote? I'm not happy.
Well, I'm looking for a Glober to join me on the Aftermath show. So maybe we could have a 3-way. I don't know.
I like you, kinky sod. But I'm up for it.
So if there's a Glober there that wants to put the hand up and be a presenter on the Aftermath show to discuss this week's presentations, again, email me, ranty@rantyflatearth.com, because I don't want it to just be a flat earther and flat earther talking on a Thursday when I'm trying to stay neutral. So I would like to sort of like mix it up a little bit, get some globe earthers to come in, and maybe some concavers in the future, who knows. So right, I think that'll do. I think Jaren's going live soon, so stay tuned for that. And in the meantime, I think I'll wrap this one up. And thanks very much, Adam. Is there anything you want to say before I go?
No, I think I've done all my plug-in and everything, haven't I? So, thanks a lot, everyone. It was fun, and the chat was a lot kinder than I anticipated. So,
yeah, no worries.
Cheers, guys.
All right, thank
Have a
you
good
guys,
evening.
and again, thank you, Earth is Seriously Flat, again, for smashing the super chat. Again, I absolutely appreciate it. And for everyone else that showed up, thank you very much. This has been episode number 10, The Curve Calculator with Adam Meakin, and I'll see you all in the next one.